Okay, so I was talking about the advantages to how the firebox is fed. The problem that other stoves have is in the feeding process, whether you're feeding it down from the top or whether you're feeding it through the side. Sometimes what will happen is in the act of feeding it, you're actually crushing the hot coals, compressing the hot coals, and you're losing efficiency in the airflow that the stove is capable to provide to those hot coals. See, in the way that the firebox feeds is you're setting this fuel in from the top, and it just sets on top of your pile of hot coals. So you've got your hot coals, you kind of feed them in on an angle from both sides, and they end up crisscrossed, your fuel. But then they burn into coals and they stay in this configuration because you're not, the act of feeding it is not crushing them. You know, you're not pushing on them. You're just setting another fresh fuel on top of them. And so that's why I would recommend with the firebox, only stir the fire if it's absolutely necessary, and generally it's not necessary. I forgot to get my ash pan in here. So, yeah, you want to keep these coals as loose as possible. So if you get in there and you stir this around, you're going to compress that coal bed, and you're going to make it more difficult for the air to travel up through and into your fire. I mean, we still have air passages to get in from the sides, but really what I've learned with all my testing is the best ventilation comes directly from the bottom, and that's the way you are able to burn your hot coals all the way to ash, allowing for more fuel to fit in the fire. But a big advantage in how the firebox is fed through these sides is just the fact that you don't have to lift up your pot. So, you know, you don't have to change what you're doing, and even if you're stirring or messing with your food that you're cooking, you know, it's real easy to just pop fuel in there as you go. Okay, I wanted to do a quick video about why the firebox does not warp. Now, I was under the impression that most of the stoves on the market today didn't warp. I just assumed that that would be unacceptable and that they probably didn't warp that much. But I've had some feedback from some of our customers who have received their firebox and have been so happy with the sturdiness of its construction and the fact that it doesn't warp. I have a customer, Steve Finnegan from France, who says he's owned several different twig burning or wood burning type stoves, hobo type stoves, and he says they've all warped. So he's really excited about this because it does not warp. And the reason it doesn't warp is because of two reasons. One, because we use 18 gauge stainless steel. Now, most of the flimsy little put-together stoves, they're made out of 23 to 24 gauge stainless steel. Now, that's a really big difference, 18 gauge to 23 or 24. And you may ask yourself the question of, well, why can they get away with using such a lightweight material and we have to use such a heavy gauge material? Well, one reason is because we don't warp at all, and number two is because the firebox is capable of putting out so much more heat. And I can't say that about all the wood burning stoves, but at least a lot of the wood burning stoves, for one, they're a lot smaller than this, so it's a big burn chamber, and because we don't have any type of fuel restrictors or fuel restrictions, you can completely fill this thing full of fuel and have a really big fire. Now, if we had a small hole in the side to restrict the flow of fuel, then like most of those the side feed type systems, they have a hole about this big, so it'll hold about this many sticks. Now the sticks would be longer, but what I'm trying to show is how much fuel is actually in the stove at one time. So if you had these long sticks going through the sides, and then inside the stove would be this much fuel. Okay, so imagine they're coming out, but this is how much is actually in the stove. Okay, well, you put this in the firebox, and you can see we're just barely getting started. The firebox can be completely filled up, and sometimes it's filled up with hot coals and becomes very, very hot. You can really put out a lot of heat. I do a boil test with a pretty full firebox with just twigs and sticks, and I'm able to boil water in 2 minutes and 38 seconds, which is just really shows how much heat is produced by a wood fire. So we have no restrictions on the fuel. Your range of BTU output is very wide. You can build a really small fire in here, and you may choose to only use this much wood. Okay, or you can go ahead and load it up and have a very high BTU stove. So we're not restricted. Some stoves, you have this much range of BTU output, but with the firebox, you have much more range of BTU output. So the stove does get a lot hotter than what a lot of the other stoves get. Now, the other reason that it doesn't warp, and I haven't explained this in the past because we've wanted to get all of our patent information all filed and all that done before we actually explained what this was. But we changed the ventilation from the first generation firebox to this current model, and the reason we did that was because we were trying to eliminate the warpage, because to us it just wasn't acceptable to have a stove that was warping. And I guess for other stove manufacturers, they just decided that they didn't have any choice, and it was just a fact of life that their stove was going to warp. Well, we came up with a solution for that, and what that is this perforated area, this perforated shape. What this does is this isolates the hottest zone of the stove. This area gets by far hotter than the whole rest of the stove. And what happens is as this area gets hot, prior to us having this perforation in here, then that area of material would expand, and it pushes on the cooler parts, and that's what actually causes the warpage. Now, by having this perforation, when, let's say, we have an upward force, it's going to be directed to this little area, and then it's going to push up, and what it's going to do is it's going to be able to just flex in that hole right there, rather than transferring that expansion into the cool zone and causing the warpage. So it's a expansion suspension, basically. It isolates and it suspends that expansion and keeps it from turning it into warpage. And this ended up being a really good thing for us, because before we had all of our ventilation kind of focused in the bottom. And what happened is, as you filled the firebox up and it built up hot coals, those hot coals would kind of block off that ventilation. And what I realized is your fire inside of here is kind of a circular shape. It's kind of like a ball of fire building materials and fire and hot coals and everything else. So I always thought that having the ventilation closer to the corners would be beneficial, because they would have less of a chance of being blocked off and clogged up. And this also allows us ventilation all the way, the whole range of the fire chamber. So no matter how full you fill it, I have a video where I fill it full of sawdust and wood pellets, and I completely fill it to the top here, but yet you can still see this row of ventilation is still available to feed it combustion air, even though it's completely full. See how the flames seem to be coming from the sides to the center instead of from the bottom up. That's because it is totally acting as a wood gas stove right now. And the reason it's doing that is because the bottom holes are fairly blocked off because of it's so built up with hot coals. And then I put some fresh fuel in on top of those, and so the air isn't coming up from the bottom, it's all coming through the sides. But that totally illustrates that secondary combustion air and how the firebox actually does work as a wood gas stove.
You have this fleece that I can use on top of her?
Yeah.
There's actually an acorn. Cool! The acorn is getting covered with dust.
With smoke?
With smoke.
You can see the smoke in the center.
And it's coming onto the acorn.
And then all the smoke combusts as the air comes through the sides. So today I'm going to put some Dutch ovens on here and just kind of see how much weight we can put on here. I've got a nice hot firebox here. It's about yay full of hot coals. And then I've got some fresh fuel up on top that's just burning right now. But I've got 12-inch Dutch ovens. And these Dutch ovens weigh 20 to 25 pounds each, just in the Dutch oven. And then the water inside weighs about 15 pounds. So there's one, and they're completely full of water. I don't know if you can see that water in there. There's one. There's two. There's three. And my last one is a 10-incher. And it doesn't weigh quite as much. It's closer to 15 to 20 pounds. I didn't actually weigh the 10-incher. And then the water inside is probably about 10 pounds. But those are all full of water. They're all filled to capacity. And that's a hot firebox. Okay, the girls and I decided we'd stay up here and keep feeding the fire until we brought this to a boil, and it just boiled over. And I couldn't get the camcorder up and running fast enough to catch it. But I think you can see the steam coming out of there now. But the boil over kind of dampened the fire down a little bit. There it goes again. So we got that bottom Dutch oven to boil over. That was pretty fun. But we still have them all stacked up here. And so there we have it. There's our weight test. We didn't test it to failure, but I like my firebox. I don't want to ruin it. And I know I'll never need to cook anything that's that heavy. So I think it passes. So I want to explain to you why we stuck with the basic geometry of the original wood flame grill, or the wood flame stove. I'm an inventor. I have a couple of patents, and I wanted to play with this design and see if there was anything I could do with it. So I got on the internet and I researched and I researched and I learned about rocket stoves, and I built rocket stoves. Here's a rocket stove I built. Here's another rocket stove I built. And I think I had one more that I built. And I played with ventilation and played with different things. And the rocket stoves actually worked really well. And they were efficient. But what I found was I was using up all my dimensional lumber. I kept on cutting up my scrap wood and splitting it because I needed straight wood to go into that feed chute. And around here, the only twigs and sticks I can find are gnarly. You know, they look more like this. So trying to feed this stuff into a chute, you end up spending a lot of time grooming the sticks and trying to get them straight enough and smooth enough that you can slide them into the chute. So I ended up using up all my dimensional lumber that way, and what I found was that it is more efficient, but not that much more efficient. And it's so bulky And I'll tell you what, if you're not there to keep that fuel fed into that fire constantly, it'll burn out really fast. If you walk away from it just for a few minutes, you'll come back and your fire will be out and your stove will be cold. So I went ahead and looked at some other designs online, and I saw that quite a few of them were conical. They got smaller at the top. You can see this one has a side feed as well. I experimented with that, and what I found with these that didn't have the collar on the feed is that the fire kept wanting to creep out. If I built up any coals at all inside of here, the fire would creep out that side feed area. And then I also found that if I had holes all the way around, then the breeze could blow directly underneath my pot, and that would blow the heat out from underneath my pot. So I could really see a big advantage of having the solid sides just like the wood flame had. So that's why we stuck with that design. But I made a whole bunch of these conical shaped stoves. That's another one. Here's a little one I did. It had a side feed as well. Same problems. They'd load up with coals and then they would choke out. Now this one, I really thought that this one was going to work better than the firebox. I thought this was going to become the new product that we would pursue. And I thought this conical shape would really focus that heat right up underneath the pot and really make it hot. But when I did a side-by-side burn test, and I had the same amount of water, the same type of fuel, we started the fires at the same time, the firebox actually boiled the water well over a minute faster than this stove did. And I thought about that for a long time, and I tried to make sense of it and figure out why. See, this stove actually has a 6-inch burn chamber. This only has a 5-inch burn chamber. So this one actually had a bigger engine. And what I realized was that the conical shape was like the top of the stove is like your exhaust. It's like your exhaust pipe. And inside here, the burn chamber, that's like your engine. So this was like having a bigger engine but a smaller exhaust pipe. So it couldn't exhaust well enough, therefore it couldn't take the air in well enough, and it caused it to choke out. The other reason that I think the firebox actually performed better is because of the radiant heat that comes from that fire. When it ignites, it releases a lot of radiant heat, just as though, you know, when you're sitting around a campfire and your blue jeans get so hot, that is all radiant heat. And so by making the top smaller, you're actually reducing the exposure of radiant heat to your pot. You're making that area smaller, and it's actually blocking some of that radiant heat. Now, the way the wood flame is set up, it's set up with the 2 high sides and the 2 low sides. And we kept that because it works so incredibly well. You can see you can feed it through the sides, so it is a side feed, but we feed it through the side top. Now, the advantages to that are you can go ahead and load that up. You can put quite a bit of wood in it, and then you can walk away from it for a little while. You don't have to sit and tend it all the time. Or if you want a really hot fire, you go ahead and load it up really big, and then you let it burn for a while, and then it'll burn down to some nice, beautiful hot coals that will be perfect for roasting marshmallows or hot dogs or anything else you want to put on your skewers. Your fire sticks actually work as great skewers.